Hi, I'm Jacqueline Magaha, and I'm going to walk you through Team 24A's experience in VEX Robotics this year. Our team is a 4-H club that is located in Westminster, Maryland. Being a part of 4-H is really special because it creates a diversity of opinions. We all attend different schools and do this club in our free time because we love robotics. By pursuing VEX, we have been able to explore our interests and identities while creating lifelong friends and a sense of pride and leadership. Since we only have 3 people on our team, we break up tasks to utilize each other's strengths. Ethan is our team's main driver and computer programmer. Alyssa has made all the CADs this competition season and is good at the big picture designs. I excel at completing the fine details of the design and am also the project manager and main communicator between other teams. At the beginning of the year, we approached this year's challenge by examining the rulebook. Our first objective was to shoot the preloads into the high goal. We also wanted to shoot in the high goal from various areas on the field. Lastly, if time allowed, we wanted to try lifting another bot 12 inches off the mat. Here is a quick overview of our first design of our robot this competition season. We used a simple roller intake to grab the balls off the floor and lead them up to a chamber, which was facilitated by a belt with flaps. Our first design throughout the majority of the competition season was a flywheel. This flywheel had a 3:25 gear ratio. It also had 2 omni wheels and 4 turbo motors. The flywheel was useful because we could score from anywhere on the field. We could do long range, short range, and midfield shooting. We were also able to score for the opponent by shooting from our starting tile into their high goal. This allowed for us to gain more SPs. We determined the speeds of the flywheel by using an LCD screen to display the velocity of each wheel on either side. We would then simply place the robot in various locations on the field to determine the velocity it needed to shoot the balls into the high goal from that distance. We had 2 attachments on this design, a ramp and catapult. We would attach the ramp when we were the field bot in the alliance. The ramp had 3 stages and would deploy by driving the wheels on the bottom forward. Each linear slide was connected to a piece of L channel. Then, plates were mounted with non-slip mat on top of them. The non-slip mat aided robots in climbing the incline. We made a heavy test spot named Brickbot to mimic an alliance partner. Here it is climbing our ramp. We used our second attachment, the catapult, when we were the long-distance shooter. We also made a device that would load 3 balls into the catapult during the autonomous period. However, we noticed that during competitions, the catapult was a lot more accurate than the flywheel. This is due to the squish factor of the balls, meaning each ball has a different hardness and softness. Catapults are ideal because they do not rely on compressing the balls. Therefore, they eliminate shooting variability. We also realized that many robots were unable to drive up the ramp. This is because they did not have a high enough clearance between the floor and their base. These major realizations caused for a redesign. We would brainstorm ideas on scrap paper or the chalkboard before transferring them to the engineering notebook. Our new goal was to make a second catapult that was designed for short-range shooting. We constructed an exact replica of our long-distance catapult. However, this one used less rubber bands to decrease the height of the ball's projectile. We kept the same drive and base as before and actually had to chain our front 2 motors to give us more space for our new intake. It consisted of 4 main parts. First, a rubber band intake made of axles and sprockets consumes the balls from the floor. Next, a car wash-like mechanism pushes the balls towards the center of the robot. There are 4 of these behind the rubber band intake. We even had to chain the 4 car wash pushers in between the main intake to stay within the maximum motor requirement. Here the balls are being attacked on the side of the rubber band intake, but they are then pushed towards the center. We then made a chamber to lift the balls off the ground to the height of the catapult. The flaps on the belt are 2/3 the size of an original flap. This size is just enough to miss the rubber band intake when the belt comes down, but to also push the balls up to the horizontal belt at the top. In this chamber, there is also a limit switch that we use in our autonomous to tell us if there is a ball in the chamber to push up to the horizontal belt. Lastly, we program the horizontal belt at the top to move the balls to either catapult. This design has been extremely reliable and lethal at competitions. Not only are we able to consume balls rapidly off the floor with our large intake, but we can also shoot well from two positions. We are able to do the preloads, be the field bot, or both. Our autonomous function is to shoot 4 preloads from the starting tile. We also made a wall on the back of the robot. This adds weight and helps us in pushing other robots when we have to play defense. We received the design award for our robot, which qualified us for the state championship on March 12th. Although this is only my second year participating in VEX, I have learned so much about robotics technically and analytically. My team shares our knowledge by mentoring our 2 VEX IQ teams, 24K and 24M. This year, we have helped organize our VEX IQ teams by teaching them time management skills. We also mentor them in creating a pusher for their robot. Fortunately, one of our VEX IQ teams has been granted the privilege to compete at Worlds. We also mentor our non-competitive 4-H Robotics Club. We create fun engineering challenges for this club to introduce the students to STEM in a friendly environment with the hope that they will become a part of our competitive VEX team. Since this is also a 4-H club, anyone in our community is able to join. I realized that VEX has not only taught me about STEM, but instead used the robot as a tool to teach major life skills, like teamwork, dedication, respect, gratitude, and communication. VEX has laid a foundation for my future and prepared me for engineering projects at WPI. I cannot wait to see how I will evolve my VEX robotics skills next fall at my future home.